This is Professor Lewis, and we're going to be working on the heat distortion test stand. And basically what we have is a heater hooked up on the bottom of a beam. The center section is cut out. We have the top portion of the beam representing a beam. We're holding it at the end and also at the other end so that we can heat the bottom half, and hopefully we should see some deflection and some strain in one half of the beam and the other half of the beam. Now we have our on and off button right here, so we can always turn it off. And we're going to be hooking up strain gauges to our beam. So hopefully you've watched the section on what is a strain gauge, and we have our wires labeled. And what I'm going to do is, because I have a top up here, I'm going to put that on channel 1, and a bottom here, I'm going to put that on channel 3. And what we're saying here is, looking at this box, this is a P3, we're going to learn how to connect this. I'm going to hook the strain gauge 1 up here to the top and the other one to the bottom. So I'm going to activate channels 1 and 3 on here. So let's go over here and make our connections to this box. Now then, we're ready to hook up our strain gauge to the P3, and we have 3 wires coming off the strain gauge. Now the strain gauge only has 2 pads, but again, we soldered the white and black wire because we're dealing with such fine measurements of current. Any resistance change is going to be notable. So we're running 2 wires to that one pad because we have to do what we call a quarter bridge here. And what we're going to be doing is hooking one side of the strain gauge here. That's going to be our red wire. And then the other side, we have 2 wires come off. That's going to be our white and black coming off the strain gauge. We're going to run those wires to this box right here, to S minus and D120. D120 represents our ohm and typically is the black wire. So all we have to do is come in here real careful like and raise these up. And I'm going to go ahead and hook up my black wire to the D120. Again, clamp it down on the exposed portion of the wire. And then we're going to come in there and clamp our white wire into place there. Now I need to come in and put my red wire in P positive, and we should have our connections made. So I'm going to go ahead and connect the other strain gauge up as well, and then we'll learn how to turn this on and use a controller. Now we've connected both strain gauges up to channel 1 representing the top gauge on the beam, and then the bottom gauge to channel 3. So what we need to do next is turn the power on, and we now have our screen coming up here. And right now it shows that we have channel 1 and 2 hooked up. Nothing about channel 3 here, because basically 1, 2, 3, and 4, just like hardwiring area. So what we need to do is hit channel. We're going to turn the channels on that we want. We don't need channel 2, so I'm going to cursor down to channel 2, move over here with the arrow, and it is now inactive. I'm going to go to channel 3. We're going to turn it on. And then I'm going to hit menu to get out. And you notice I have 2 channels showing up on the screen here, channel 1 and 3 to our wiring. The next thing we have to do is tell what kind of bridge we're wiring up to. Now we're using a quarter bridge that we talked about, and so each channel, 1 and 3 here, we need to get to a quarter. If for some reason, I'm going to act like this channel 4 we were using, it's undefined right now, I could go through and change and get to a quarter. And right now all 4 channels are set up for quarter. So if I hit menu, all 4 channels are set up for quarter bridge. I only need to change 1 and 3. Now then, we need our K factors. K factor for the strain gauge is something that you get off the back of the strain gauge. And we're going to, again, do channel 1. To change the channels here, you could go to channel 3 right there. And we can see channel 3, we're going to have to fix something there. Because channel 1, we're on microstrain. So if it's not on microstrain, you can go down here and change until it gets to microstrain right there. There's degrees Celsius, there is microstrain. We're going to cursor down here to gauge factor, and our gauge factor should be 2.040, and that looks good. So let's go up to channel 3, and we're going to go change that to our value. So I'm going to cursor over here and change this value. And sorry, the screen on this unit is one of them that just doesn't always keep a real good resolution. So we now have our gauge factor at micro units. We can hit menu, and we now have set both of our strain gauges on there. You notice everything is pretty well staying the same. If I move the table, I will get some variance in those because it will pick up any little bit in all vibrations in there. Now what I'm going to be doing is we're going to go over and turn the machine on and time it, and we're going to watch the strains on these. But before we do, we need to balance these out. So we're going to hit balance, and this is like a scale where we tear it out and we zero it. We don't want to be pushing on the beam or moving the table. And then we're going to hit record twice. And now these are both zeroed out. That means the strain gauges are zeroed out. Anything that we do to that beam, heat making it expand, putting strain on it. We're going to record that here. Now what we're ready to do is finish our setup here on the machine, because we're going to be measuring deflection on this. And what we want to do is take this tool right here, and if we push the trigger, it's going to shoot 2 dots out, and we want to get the 2 dots on the same point of the beam, so we'll have to focus them, and if I move out you can see them coming together. And that's going to give us a good temperature. So what I'm going to do is measure the temperature on that top beam right there, and then the bottom beam, and make sure that they're the same. And they should be at room temperature. We want to do that because we may have other groups that have used this, and we need to make sure it cools down all the way back to room temperature. And it only takes maybe 15 minutes to do that. What we're going to do next is come in here and we're going to set a dial indicator on this beam, and you can pull this up real careful here. Now don't loosen it and tighten it from that side. That's holding the gauge tight. This is tightening it and loosening it on the main post here. Now I'm going to slide this up onto my part, and I'm just going to let the dial indicator hit on the part. Now if I lower the part down, I can see it flexing the needle there. So I know I'm at a good point. The other thing is I want to be at 0, because as this thing raises, I can watch it go 1 revolution, and I can see that needle right there going to 1, so I can count the number of revolutions. The one thing I need to do is probably come in here and turn the bezel face so that I'm actually at 0 there. So now we have our dial indicator set, so we can actually see if this thing raises up or down and kind of get a feel for what's happening to the beam. What we're going to do is rebalance out, so hit balance, balance, save, and save. And we have now zeroed out the strain gauges again, because we might be putting just a tiny little bit of force from that gauge pushing down, and so we're going to balance it out so it's 0 again. Now what I'm going to do is come in here, and I've got my stopwatch, and we have the on button, and when we turn this on, this is going to get hot, so we need to take a safety note. Do not reach in here and touch, because you're going to see this get nice and red and hot. So assume everything's hot in here and keep your hands out of the work area of that unit right there. Now what I'm going to do is go ahead and hit start here and start my time, and I now am timing this heating up. What we're going to see are the heater elements are going to get really hot there. So I'm going to keep my hands out now like I told you guys, and I'm going to use my ruler, and we can see the heating element down there heating up. Now the top beam up here is cold. We don't have heat connecting from one beam to the next. I kind of acted like cutting the center out because I just want to heat the very bottom half of the beam and not the top half. So if I was to take temperatures, you're going to probably find this half of the beam not heating up and this one heating up. Now it's going to take time because we're not heating it all the way the full length for the heat to evenly heat up that whole beam and get it to where it's going to be at its optimum strain level. And then what we're going to call that is when we get the same strain in the bottom as in the top, but opposite. So hopefully this is going in one direction. If it's heating up, it should expand. So we should see positive strain going there, and we should see negative strain there. So once we get to the two values being the same but in opposite directions, let's stop our machine by hitting off and stopping our time and take note of that. And also we're going to watch the deflection, and if I notice, look at my deflection. Just in the time we've been talking, my deflection is moving. Now that means this beam is rising up at the end down here. The other end of this beam on this side is not going to move because it's hooked to a real rigid steel frame. So if that beam's flexing up or down, it's going to be noticed out there on the end, and those are hooked together solid so that as the coupling goes, it's going to stay together. So at this point I went ahead and stopped the timer and pushed off because the strain on the bottom is the same as the strain on top, and I got up to a certain value, and you can read those as you do your experiment and see how much deflection you had or didn't have. Now as it cools, I can see the change in deflection headed the opposite direction, and I can see the strains relieving as well. So this is just a neat experiment to see stress being built up, which can also be related to strain. And if we were to heat up a member, and again in the lecture, the prep lecture, we talked about maybe things like welding, flame cutting, and all that. And theoretically, we could create enough stress in a member that it would permanently distort that part. The last portion of this lab is going to be dealing with finding the coefficient thermal expansion for aluminum. And we have 6061 T6 aluminum. So we can look that up and get a value of what it should be, but we want to experimentally determine what that value is going to be. So I would suggest not handling your measurement tools too much or even the sample, because we're going to have to let this sample get to room temperature. So let's go ahead and measure our sample real quick and then get it on the table. Now this is a digital caliper, and you're going to want to zero it out, make sure your blades are clean, and this one will read down to 0.5 thousandths. Now don't just roll it out to full length real fast or it will air out on you. Go slow, and what you're going to have to do is come up here very carefully and seat that part up, and you're going to have to measure how long that part is. Once you get it done, write that down and measure it 3 or 4 times, taking the average length of that part. Now make sure it's all squared up, because this is going to be very important to get really good readings here. Once you get that done, let it sit for a while, and we're going to let it acclimate to the room temperature. Now one way we can tell that is we're going to hook up our strain gauge to the P3, and we're going to hook it up the same way with the quarter bridge. So red wire goes to P positive, white wire to S minus, the black wire is going to go to D120. We're going to turn on the unit, activate channel 1. We're going to go down here and we're going to put it to quarter bridge, and the K factor, we're going to do micro strain, and we're going to go with the gauge factor at 2.040. Once we have those, we're going to come over and balance that out. So I'm going to turn this on right now because I've already set all that up in here for myself, and I'm going to hit balance, and hit record twice, and I'm going to watch the strain, and hopefully it will go to 0 and stay at 0. If it's coming down or going up, then it's basically heating or cooling to the room temperature. Once I get that where the number stays the same, I'm going to come over here with this nice temperature measurement device, and again it shoots 2 dots out there. We want to get the dots together, and we're going to measure the temperature on that part. So I'm going to come in here, and it reads my temperature, and I can write that down on my lab report. Get it to where the strain is not changing, we're at room temperature, and then we have this wonderful box of ice, and we're going to have that zeroed out. We're going to drop our sample down here, put the lid on, and we're going to watch the strain. Now you want to go till the strain stops and give it 5 minutes to 10 minutes, somewhere in that range, so that we can get that sample totally to temperature, and the temperature of ice, you should know what that is. And what we're going to do then is carefully take that out, and smartly, very quickly, we're going to measure the length of that sample, and we're going to be able to find out if it expanded or contracted, and then we're going to be able to go calculate our coefficient of thermal expansion for that. Now that should finish up this lab.